All right, next question is from, I'm going to say that's Linda. Yeah. um, let's see. Hi, Dr. Ben. Can you explain the infective dose and the viral load? Well, of course. Yeah, happy to. Yeah. I heard a mathematical. I heard a medical professional, there we go, state that you could be exposed to a small amount of virus and not trigger an immune response. Maybe, yeah. But the number of virus to create an immune response but the number of virus to not create an immune response would be very low. Yeah, okay, we're asking about that. And if you were exposed to a few cells, would you build up, like a few viruses, would you build up immunity without being infected? Yeah, okay, fine. So there is no good way to build up immunity to this virus without either being infected or vaccinated. And right now, there aren't any vaccines, so yeah, if you were inhaling like massive amounts of, like um, just yeah, doing lines of ground up coronavirus that was definitely inactivated, that would be something like vaccinating yourself. I don't think anybody, even in a hospital, is in a situation where they would be sort of accidentally breathing in that amount of inactivated virus. Yeah, most people are being exposed to the live active version of the virus, which is a little scary. Um, and so, no, as far as I know, there's no way to develop immunity without having that virus right inside your body. There are a number of cells that have to see the virus and grind it into pieces and hold out the pieces and show each other and learn how to kind of adapt and fit onto those pieces. This is, I mean, there's a whole immunology course, yeah, the kind of, to explain the full answer to that. But no, I don't think that's possible. As for the first part of the question, which is actually good, these are neat things. So, infective dose is how many individual viruses it's going to take to actually start an infection. And this is a thing that we do not yet know for SARS coronavirus 2, and we may not ever know for certain. We'd be able to say what the infective dose is for a mouse or a hamster or something like that, but you can't do that experiment where you give different doses and then say, oh yeah, okay, now he or she is infected. Great, yeah, with people that's not okay. So from the animal work, we think that it's going to be on the order of thousands, somewhere between the lowest I've heard was 1,000. The highest I've heard was actually 10 to the fifth, so 100,000 copies. And I don't know, in the mouse model with a related coronavirus, it's right about in the middle there on a log scale. Yeah, because we always deal in log scale. So about 10,000 copies to start an infection. It's not because you necessarily need 10,000 of them, although there is one line of thinking that could mean exactly that you would need to start with a lot of different copies. It's called quasi-species theory, but that's for a different lesson. We don't need to go into that. Um, but yeah, it's more like each one is not likely to start an infection, but if you get enough of them, then inside of you, then there's a chance that they'll start an infection. Now, the virus load is how much virus you actually have in either the entire body or in a particular part of your body. And so this is exactly what they'd be measuring with the PCR test. Which would be done on either swab or fecal sample would be very nice. And oh yeah, there we go. Yeah, helicopter raid, I guess. Um, so yeah, viral loads, how much you've got inside you. Infective dose is how much it takes to start the infection. Can you have just a small infection that doesn't make a very good immune response? Maybe, but it's very difficult to actually prove that you were infected because the way that we would prove that is by either showing that you have the virus inside you, and it takes a lot of virus to do that, or showing that you have an immune response to the virus, which means that yes, you were infected. I think it's not. I don't think a little bit infected is really a thing, but some people control the virus better than others, for sure. And so there will be differences, but then there's a whole nother layer of genetics and immunology on top of this that at present only partly explains why some people have maybe immunity that lasts longer than other people. That's something that's still being very much worked out, but we know a little bit about it for other viruses. So, yeah, all right, that was a rambling answer, kind of went all over the place. I hope there was something in there that helped you a little bit at least. Thanks very much. This is Ask Dr. Ben.